So welcome back to VRC Smart Edu channel. Kindly like, share and subscribe our channel. This is a part 2 video of the chapter 8 Gravitation. Here we will be discussing about Newton's law of gravitation. And let us recall our previous session before going into Newton's law of gravitation. In our previous session we discussed about Kepler's law of gravitation. And if you have not watched our previous session, kindly watch it. The link is provided in the description. You can go and check it out. And now let's recall our previous session, what we have learned. So in our previous session, we learned 3 laws of Kepler. First law, second law and third law. We learned 3 laws of Kepler. So in that, now we are going to just look after the question based on the third law of gravitation, Kepler's third law of gravitation. Now, let me read the question once and let us try to solve the answer for this question. The distance between the earth and sun were to be doubled from its present value. The number of days in a year would be. So, options are given here: 64.5, 1032, 182.5, 730. You have to choose which is the correct option. So now let us try solving this problem based on the formula that we learned. The formula that we learned is T square is directly proportional to A cube. This is the formula that we learned. Okay, very important formula. Now they have given us 2 different time period and 2 different length, right? Our T1 is going to be 365 days, right? They have given 1 year, right? And our A1, let us imagine A1, and from there it is doubled. The distance is doubled. If our A1 is A1, then our A2 will be what? Then our A2 will be what? A2 will be equal to 2A1. If our A1 is A1, our A2 will be equal to 2A1. So now this is what you have to know. That is given from the question. Now you have to find T2. What do you have to find? You have to find T2. T2 is what you have to find given in the question. Now these are the given details. Now if you have to find a T2, now I am going to take the ratio. That is the easiest way of finding T2. Now how to take the ratio? T1 square by T2 square is equal to A1 cube by A2 cube. Right? You can do like this. Now I need is T2. This one only I need, T2. So how can I do that? T2 square is equal to this. I am going to bring to this side. So you can rearrange and write it like T1 square into A2 cube by A1 cube. Right? Now how can I just rearrange and write it? I can write it like, so I have to rearrange and write it, that's all. So this is initially what we have written. So we have T2 square is equal to T1 square value we know 365. So 365 the whole square into, actually if you see here, A2 cube by A1 cube. You can write it as A2 by A1 the whole cube, right? You can write it as simply, you can write it as A1, A2 by A1 the whole cube, right? A2 by A1 the whole cube. Now, as per our previous slide, we know that A1 is equal to A1, A2 is equal to 2A1. So now, A2 by A1, if I have to write it in the ratio form, how can I write 2A1 is to 2A1 is to A1. So A1 and A1 gets cancelled, so you will get 2 is to 1. So if I substitute the ratio in the division form, what will happen? T2 square is equal to 365 square into 2 by 1 the whole cube. So what is 2 cube? 2 cube is 8, right? So T2 square is equal to 365 the whole square into 8, right? 2 cube is 8, 1 cube is 1 only. Since it is in denominator, it doesn't have any value, so you can leave it off. Now, what I'm going to do is, T2 is equal to square root of 8 into 365 the whole square. I'm going to square this entire value. Now, what I will get is T square is equal to square root of 8 into 365. Since it is under square root and it is in multiplication, you can take only one time. 365 you can take only one time. Now, square root of 8 can be written as, 2 root 2, right? So, what will happen? Your T2 is equal to 2 root 2 into 365. And your root 2 value is equal to, your root 2 value can be equal to 1.41. You can take your root 2 value as 1.41. So if you just take this root 2 value and substitute here, and you just multiply all these values, you get your T2 as equal to 1032. If you just calculate this value, entire value, you will get your T2 as 1032. So if you see the options here, given listed options, you have the listed options here. A option is 64.5. So your correct option is your B option, which is 1032, right? Okay. So hope you got a clarity on a previous session. So now let us move to today's session, that is Newton's law of gravitation. Okay. Before that, one more topic in the previous session. So at aphelion, earlier we discussed that the sun is present at one of the focus, right? So this is a diagram. So sun is present at one of the focus. Here some sun is present means these are the 2 points you have. One is aphelion, another one is perihelion, right? So how will be the kinetic energy at aphelion and how will be the kinetic energy at perihelion? Kinetic energy at aphelion will be less, okay? Kinetic energy at aphelion will be less. Kinetic energy at perihelion will be more, okay? Potential energy at aphelion will be more, okay? Potential energy at perihelion will be less, okay? This one is important to remember, okay? Kinetic energy and potential energy. Clear? Right. So now let us move for the very most important topic, Newton's law of gravitation. Newton's law of gravitation. Okay. What does Newton's law of gravitation states? What does Newton's law of gravitation states? Actually, now I am going to read the statement. Later I will explain. Every particle attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Okay. Now imagine these are two particles. These are two massed particles, m1 and m2. So masses of the particles are denoted as m1 and m2. So what happens is always there will be a force of attraction between these two massed particles. That is, this particle will have force at this side, this particle will exhibit force at this side. The attraction force will be acting on both the sides of the particle. So we can say that if you consider the particle with mass m1 and m2, then I can say r is the distance between them. R is the distance between them. Then the force of attraction of the particle is denoted by, already we have studied the same in the definition, that we are going to express in the mathematical form. Okay. Then your F will be equal to, so already we studied F is directly proportional to m1, m2, masses of the two objects. When mass is increased, your force will also be increasing, right? And your F is directly proportional, inversely proportional to the radius square. When your distance, see, your masses are like this, One of your mass is moving in this direction, another one of your mass is moving in this direction. So when your force is more, what happens? Your distance gets reduced. So only we are saying that your force is inversely proportional to the radius square. So join this both of the equation, what you will get? Force is directly proportional to m1 m2 by r square, right? So now what I am going to do is I am going to remove this proportionality symbol. So for that I am going to introduce a constant, that is going to be your gravitational constant. F is equal to g m1 m2 by r square. Here what I have done, I have introduced the gravitational constant to remove the proportionality symbol. Clear? So here what is that? Here g is your gravitational constant. Your g is your gravitational constant. So very important thing now we are just discussing is the value of g. The value of g is really important to remember, and the SI unit of g and the dimensional formula of the g that we are going to discuss here. The value of the g is nothing but 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is the value of universal constant. Okay. Then what is its SI unit? Its SI unit is Newton meter square per kg square. It is its SI unit. What is its dimensional formula? What is the dimension of gravitation? So actually we used to derive the dimension of the gravitation from the SI unit. We can easily derive the dimension of the gravitational constant. Okay, so now you have Newton meter square per kg square. So how can you derive Newton meter? Actually Newton's SI unit actually you have is for force, whatever you use. So you can substitute the values of that, and when you substitute you can able to get the dimensional formula as m to the power of minus 1, L to the power of 3 and T to the power of minus 2. This will be your dimensional formula for the gravitational constant. Clear? This will be the formula for your gravitational constant. Now let's move on to the next concept. It is nothing but vector form. You are going to just represent it, this equation in the vector form. How can you do this? How can you represent it in the vector form? Okay. So now let us see. So vector form. So if you are talking about the vector form, first I am going to write the formula. F vector is equal to, you have to represent everything in vector. Okay. G, m1, m2. Masses are constant, so they will not be coming under vector. By r square is a distance, so it will not be coming under vector. But here we are going to represent r vector. What is this r vector states? This r vector states the direction on which the object is moving. So this r vector is showing the direction. So here we have the r vector. So this is the, what I can say is, this is the force exerted by an object. So we have two objects, right? Mass containing mass m1 and m2. We have two objects containing mass m1 and m2. So here we can say that the particle is moving from m2 position to m1. Okay. Here we can say that the particle is moving from m2 position to m1 position. Okay. m2 position to m1 position. Here the particle is moving from m2 position to m1 position. Now if I go for the next, how can I represent this? F dash is equal to minus g m1 m2 by r square. Okay, so while I am representing it like this, my r vector is like this. So your r is going in the opposite direction to the one that is above, right? So it is going in the opposite direction, that is your object is moving from the position M1, it is moving to position M2. Okay, so here these are the two objects. This is your M1, this is your M2. Initially what happens is your M2 moves towards the M1. So that is represented as F vector. Okay, now next what happens, your M1 is moving towards your M2. So that is represented at this case. So what happens is, why this negative sign is placed here, it indicates the direction, change in the direction, right? So finally I can conclude from the equation 1, this is considering it as equation 1, equation 2, from this two equation I can conclude that your F vector is equal to your minus F vector. That is, your F vector is, if one vector is moving this side, the another vector will move on the opposite direction. That is what we are concluding from the vector form. Okay, right. Now let us see some important points based on the gravitation. Really important points, these are all to keep in the mind. Okay, right. So our first point is, gravitational force is a conservative force. Yes, gravitational force is a conservative force. It will be conserved, right? Okay. Next, it is a central force. So always your force between two objects. For example, this is your M1 object. This is your M2 object. The force between these two objects are acting means always the force will be acting from the center. In this way only your force will be acting. So it is a central force. Okay. It is a central force. Then it obeys action-reaction pair. That is Newton's third law. That is, now we have proved, no, in vector form we have proved F vector is equal to minus F vector. We have proved that, right? So this statement states what we have proved in our vector form, right? It obeys action-reaction pair. Okay. It does not depend on any medium. It may be liquid, it may be solid, or it may be a gas. Whatever the medium it may be. So whatever the medium it may be, it does not depend on any medium, it is independent of medium, right? It is independent of medium. It is always an attractive force, right? It's an attractive force. So see, whenever gravitation is involved, what happens? Your masses of the two objects are getting attracted towards each other. So we can say that it is an attractive force, right? Okay. So this is what today's discussion, and I have got a question for you to solve. So let us solve this question based on today's discussion. Okay, right. So the question states here is, the masses of two spherical bodies are quadrupled and the distance between their centers is doubled. How many times the force of gravitation will be between them will be changed? So this is a question. Okay. Now what they are stating, according to that I am writing, masses of the two spherical bodies are quadrupled. Okay. So you have first M1 is your first spherical body. It is quadrupled. Quadrupled in the sense becoming 4 times greater. Both of your objects, M2 is also becoming quadrupled for M2. And they are saying your radius from the center, your distance from the center is doubled. So your R is also getting doubled. Okay. So now initially I am going to take the phase. Initially I am going to take the phase as F1 is equal to, this is our formula, right? G M1 M2 by R square. Right? So this is our first force that is acting on the body. So when the force is getting changed, after the change of force, what happens? It is becoming as G M1 M2. I am just keeping it as M1 M2, right? So capital M M1 M2 M1 M2 by R square. Now you know the value of R, you know the value of M1, and you know the value of M2. Just substitute that. This is your second force. F2 is equal to G into, actually what is your M1 value? It is 4 M1 into 4 M2 by divided by 2r whole square. So this is what you are getting, right? So when you expand it, what happens? 4 4s are 16. So your F2 is equal to 16g m1 m2 by 4r square, right? So this 4 and 16 can be cancelled 4 times. So your F2 is equal to, see this case, in this case if you just look after this g m1 m2 by r square, what is this? This value is your f1, right? So instead of that I can write f1, instead of this value I can write f1. So now what I am going to do is, instead of your g m1 m2 by r square, I am going to write 4f1. So they are saying that how much the force of gravitation is changed. So you can write the solution as, the force, the gravitational force will increase, the gravitational force will increase 4 times the initial magnitude, 4 times the initial magnitude. Okay, 4 times the initial magnitude. Your gravitational force will increase 4 times the initial magnitude according to this what we got. Clear? Okay. So thank you so much for watching this video. Kindly subscribe our channel and click the bell button for future videos. And thank you so much.